Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to be talking about quadratic functions for SAT subject test math level 2. Now this is a video which is specific to this test, so if you're actually practicing for this test, then this is the best video for you. So let's go ahead and get started guys. So if you watched the previous two videos in the playlist, as you know that we've covered the whole syllabus in this playlist, that you would have seen the functions video, and after that you would have seen the linear functions video. Now what we're going to do is we're going to be solving quadratic functions, right? Now linear functions are of the form y is equal to ax to the power 1 plus bx to the power 0. But what are quadratic functions? Quadratic functions are next level functions. That is, y is equal to ax to the power 2 plus bx to the power 1 plus cx to the power 0. So these functions are known as quadratic functions, where the maximum power of x is actually 2. So the maximum power of x is actually equal to 2. Now the most simplest quadratic function that you will see, it's simply y is equal to x squared. This is the most simplest quadratic function. Now if I go ahead and kind of plot this function, if I say the value of x and the value of y, if x is 0, y is 0, if x is 1, y is 1, if x is negative 1, y is 1, if x is 2, y is 4, if x is negative 2, y is 4. And if I kind of go ahead and plot this function on the x and y axis, let's say this is x axis and this is y axis. When x is 0, y is 0. When x is 1, y is 1. When x is negative 1, y is 1. When x is 2, y is 4. When x is negative 2, y is 4. So this is how this function looks like. So this is a typical quadratic function. That is, y is equal to x squared. However, if you look at many other quadratic functions, let's suppose I want to look at y is equal to x squared minus 5x plus 6. Now this function is actually going to cut the x-axis at two different points. Now these 2 points are known as the roots of the function. Now what are the roots of the function? These are the values of the function where y is equal to 0. This point over here is known as the y-intercept of the function. What is the y-intercept of the function? Where x is equal to 0. And this point over here, that is the lowest point, is known as the this lowest point is known as the vertex of the function, right? So there are three things that you have to know: the roots of the function, the vertex of the function, and the y-intercept of the function. So what we're going to do is we're going to find out different ways of solving the roots of the function. So let's go ahead and find those different ways, learn those different ways of solving the roots of the function, right? So let's get started. First thing is that I'm going to talk about is that if I say that we have a general equation, that is y is equal to x squared minus 5x plus 6. The first way of solving the roots of the function is splitting the middle term. So what you do is you split the middle term, right? How do you split the middle term? What you do is, I think you must be knowing this already because you're writing this subject test math level 2. You would find two numbers. So if I say y is equal to x squared minus 5x plus 6, you will find two numbers whose product is 6 times 1 and whose sum is negative 5. So I'll have to find two numbers whose product is positive 6 and sum is negative 5. Well, those two numbers are negative 3 and negative 2. Now what you're going to do is you're going to split this middle term into negative 3x and negative 2x. So this is going to become x squared negative 3x and negative 2x plus 6. You're going to take the x out. So what you're going to do is you can take something out from it, something common that is there, that is x. So x remains here and 3 remains here. From here you take negative 2 out. What remains? X remains, and again negative 3 remains. Now this and this should be equal, which you can actually take out as x minus 3. And from here x remains, and from here 2 remains, and this is your function. So y is equal to x minus 3 into x minus 2. So this is what you do. You kind of factorize the quadratic function and you bring it to this format. Once you bring it to this format, now what you have to do is, let's suppose you have to find the roots. Now if you want to find the roots would be this value. That is the value of the function where y is equal to 0. That means the value of the function where the value of y is equal to 0. So that will be equal to 0 if x minus 3 is 0 or x minus 2 is 0. That means either x is equal to 3 or x is equal to 2. That means these are the two roots of the function. And understand, a quadratic equation will have maximum of two roots. So these are the two roots, that is 3 and 2, at which this function cuts the x-axis. That means at here and at here, that means x equal to 2 and at x equal to 3, the function is going to cut the x-axis. Now how do you find the y-intercept? To find the y-intercept, what you do is you substitute x as 0. So if I substitute x as 0, I'll have 0 minus 3 and 0 minus 2, and y will be equal to 6. That means the function over here, this value is actually equal to 6. So this is how you split the middle term and you find out the roots and you find out the y-intercept of the function. Now, what you can do is, another thing that you can do, sometimes you're not able to split the middle term. Then what you do is you use the formula. Now, what's the formula here? Now, if I say I have a quadratic function, y is equal to ax squared plus bx plus c. Let's suppose this is a quadratic function. Again, understand, I'm reviewing quadratic functions here. I'm not deriving anything. If you want to see the derivations, we have separate videos for that. So what you can say is the roots of the function, let's suppose these are the two roots of the function. The roots of the functions are going to be given by this formula, that is minus b plus minus square root b square minus 4ac divided by 2 times a. These are the two different values, one plus something and one minus something, that will give you the value of these roots, this root and this root. So two values would be given by this root. Now from here what you can do is, you can actually say, let's suppose this b square minus 4ac, let's say this b square minus 4ac is known as the discriminant. Why this is known as the discriminant? I'm going to tell you right now. If this discriminant is greater than 0, that means you're going to have your two roots to be equal to minus b plus or minus something divided by 2 times a. That means you're going to have two different roots, one plus something and one minus something. That means when d is greater than 0, you will have two real roots. And when this d is equal to 0, that means your function, this value would be equal to 0. The value of your function is simply going to be equal to minus b over 2a. That means you will get a single root, but a real root. Here the graph will cut the x-axis at two different points when d is greater than 0. When d is equal to 0, the graph will just touch the x-axis, right? So one of the example of this function would be y is equal to x minus 3 whole square. That is one of the examples of this function. Another thing is, the next thing is when d is less than 0. When d is less than 0, what happens is that when d is less than 0, what happens is that this value becomes under root of a negative number. So what is under root of a negative number? Under root of a negative number is a complex number. It's an imaginary number. That means when d is less than 0, you get two imaginary roots. So what do you get? You get two imaginary roots. Fine. So when d is greater than 0, you have two real roots and two distinct real roots. And when d is equal to 0, you have a single root. And when d is less than 0, you have two distinct imaginary roots which are conjugates of each other. That means if one of the root is 2 plus 3i, another root would be 2 minus 3i, because you will have 2 plus something I and 2 minus something I. So I hope you're able to understand what I'm trying to say here, guys. So this is how the formula works in this. Fine. So let's go ahead and learn more thing about this. How do you know the value of vertex? Now let's suppose when you have, let's suppose this is your quadratic function and these are your two roots, right? Let's say this is your quadratic function and these are your two roots. Now this root is going to be equal to minus b over 2a plus square root discriminant. This root is going to be equal to minus b minus root discriminant over 2a, as you can see, or let's say this is minus and this is plus, because as you can clearly see that you have two different roots, minus b plus root discriminant over 2a and minus b minus root discriminant over 2a. Now this, as you can clearly see that this point over here and if I draw a line from this point, that will actually cut the whole parabola. This is something which is known as this is something which is known as a parabola. The whole parabola into two equal parts, which means this value here would lie exactly in the middle of these 2 points. And how do you find the midpoint? The midpoint can easily be found by finding the average of these two numbers. So if you find the average of this number, and if you kind of add both of these numbers and then divide the whole thing by 2, you will get the midpoint of this to be equal to minus b over 2a. That means the x coordinate of the vertex is always equal to minus b over 2a. So what is the x coordinate of the vertex? The x coordinate of the vertex is always going to be equal to minus b over 2a. So if you have any quadratic function, let's suppose x square minus 5x plus 6, what is going to be the x coordinate of the vertex? X coordinate of the vertex is going to be 5 over 2 times a, that is 2, that is 2.5. So that means the quadratic function is going to be like this. The root is 2 and 3, and this is the x coordinate is going to be 2.5. And if you want to find the y coordinate, just substitute that x coordinate into this function and you will get the y coordinate. So the y coordinate here would be equal to x square minus 5x plus 6, right? So this is how you'll get the y coordinate. So you can find the vertex of this parabola by using this value, that is minus b over 2a. So that is that. Now another good thing that this vertex does is, so if you have a parabola, let's suppose y is equal to x square minus 5x plus 6. As you can clearly see, this is how this function looks like, and this is something which is minus b over 2a. X is equal to minus b over 2a. So if you draw this line x is equal to minus b over 2a, this line becomes the line of symmetry. What do you mean by line of symmetry? Line of symmetry means it cuts the whole parabola into two equal parts, right? So that is something which is known as the line of symmetry. So if you have any parabola, let's suppose y is equal to x square of x square plus 4x plus 6, then x equals to minus 4 over 2, that is x is equal to negative 2, is going to be equal, it's going to be cutting, this line is going to be cutting the whole parabola into two equal parts, right? So I hope you're able to understand what I'm trying to say here, guys. Now, the next thing is about these parabolic functions is the value of a. What happens if the value of a changes? So if I have a quadratic function, let's suppose y is equal to ax square plus bx plus c. Let's take a simple example. How does y is equal to x square look like? Y is equal to x square looks like this. And how does y is equal to negative of x square looks like? If you multiply the coefficient of x square with a negative number, the graph will flip. The graph will become like this. So if a is greater than 0, then this is how a parabolic function is. But if a is less than 0, then this is how a parabolic function is. Right? I think you can easily make out the trick here. If a is greater than 0, then this is how the parabolic function is. And if a is less than 0, this is how the parabolic function is. Now another thing that I would like to explain here is the sum of the roots and the product of the roots. So if I have a quadratic function y is equal to ax square plus bx plus c, as you can see that the value of two roots is given by minus b plus or minus, for one root is this and another root is this. And if I want to find the sum of the roots, it would be equal to, you add them up, it would be equal to minus b over a. If I want to find the product of the roots, if you multiply them up, the product of the roots would be c over a. So the sum of the roots is given as, minus b over a, and product of the roots is given as c over a. You can easily verify it from here. If you add them up, d and d will get cancelled. It would be minus b over 2a, which is going to be equal to minus 2b over 2a, which is actually minus b over a. Same, you can do a lot of manipulations, and at the end you will get the product of the roots to be equal to c over a. So sum of the roots is minus b over a, and product of the roots is actually equal to c over a. Now the next thing that you're going to do is the domain and the range of uh, quadratic functions. Now domain is something which tells you all the x values. Domain is something which tells you all the x values, and range is all about the y values. So if I have a quadratic function y is equal to, let's say, y is equal to x square minus 5x plus 6. Now here x can take any value, isn't it? Here x can take any value, but what about y? So if I have a quadratic function, then y will not be able to go beyond, y will not be able to go below this specific value, isn't it? So y will not be able to go below this, which means y always have to be greater than this value. This is how you get the range of this function. So I hope you're able to get my point. Another thing is that if a is less than 0, then this is how the quadratic function looks like. That means y cannot go beyond this. That means y cannot go above this value. That means y will always stay less than this function. Let's say if I want to talk about a function here. Let's suppose if I say that, let's say that the function is y is equal to x square minus 5x plus 6. This is something that we easily transform to x minus 3 into x minus 2. Now how does this function look like? This function looks like this. Now let's say I want to find the range of this function. That means I want to find out what all y values are there. So as you can clearly see, the x coordinate of this vertex is 2.5, that is minus b over 2a, which is actually equal to 5 over 2, which is 2.5. What is going to be the y coordinate? The y coordinate would be equal to 2.5 whole square minus 5 into 2.5 plus 6. So this is going to be 25 by 4 minus 25 by 2 plus 6. So this is going to be equal to that is going to be equal to, so if you multiply this by 2, you multiply this by 2, so 25 minus 50 is minus 25 by 4 plus 6, that is minus 25 plus 24 over 4, that is minus 1 over 4. So here the y value is actually equal to minus 1 over 4. That means you can say that y will always stay greater than minus 1 over 4. This is the range of this function, that y value will always remain greater than minus 1 over 4. So I hope you're able to understand how do you find the range of these functions, right? So that's actually pretty important. Now another thing that I want to do is the quadratic inequalities. So another thing that actually can be asked are quadratic inequalities. So let's suppose if I have a function x square minus 5x plus 6 has to be greater than 0. What all values of x will be there? So what you do is we factorize this, we find the value of the roots. So this is how this function is going to look like. So now we want the value of this function. What is this? This is nothing but the y. We want y to be greater than 0. Where is y greater than 0? At all these x values, y is greater than 0. Now this is x is equal to 3 and this is x is equal to 2. Right? These are the roots of this function. That means at all the values x greater than 3 and at all the values x less than 2, that means x has to be greater than 3 and x has to be less than 2. At all these values, this function would be greater than 0. So this is how you solve the quadratic functions. So what you do is, I'm going to write down the steps here. So first thing what you do is you factorize your function just like the way I've done here. You find the roots, you sketch the graph, and then you look for the inequality that you're looking for. Then you look for the value of x which satisfy your inequality. Let's say for example, if I say that I have a function that is let's say x square minus 5x plus 6 is less than 0. I want to find that. First I will factorize the function, then I will find the roots. The roots are 3 and 2, and 3 and 2 look like this. I want the function to be less than 0. Where is the value of y less than 0? At these points the value of y is less than 0. That means x greater than 2 and x less than 3. So that means x greater than 2 but x less than 3. At these values this function is going to be negative. rest all the values, this function is going to be positive. So I hope you're able to understand what I'm trying to say here, guys. Right? So that's there. Now let's go ahead and analyze this quadratic function. Let's try to find everything about it. So y is equal to negative x squared plus 4x plus 5. Now, if I want to find out the value of the roots, right? So if I want to find out the value of the roots, 5 into negative 1, the product of the numbers should be negative 5, and the sum of the numbers should be actually equal to 4. So how is going to be the product of two numbers negative 5 and sum equal to 4? That will actually be 5 minus 1, right? 5 and minus 1. So if I break this, this is going to be negative x squared plus 5x minus 1 plus minus x plus 5. This is going to be x. I'm going to take x out. I'll be left with minus x plus 5, and I'll be taking out minus 1 out. I'll be left with x. I'm sorry, I'm going to be taking positive 1 out. It's minus x plus 5. So that is nothing but 5 minus x into x plus 1 is equal to y. And what are going to be the roots? The roots would be where the y is equal to 0. That means x would be equal to 5 or x would be equal to negative 1. So if I draw this function, x would be equal to negative 1 or x would be equal to 5, and this is what the function is going to be. If you want to find the coordinates of the vertex, the x coordinate of the vertex would be given by, now hold on, I've actually made a mistake here. As you can see that the coefficient of x square is negative, then the function is actually going to look something like this, right? So this is how this function is going to look like. And if I want to find the x coordinate of this vertex, the x coordinate of the vertex is going to be given by minus b over 2a. So what is minus b over 2a? That is here. That is minus 4 over 2 times minus 1, which is actually going to be equal to 2. So the x coordinate of the vertex is 2. That means x is equal to 2 is the line of symmetry. X is equal to 2 is the line of symmetry that actually cuts the whole graph in two equal parts. Fine. And so this is everything about this quadratic function right here, and that's actually pretty easy, right? So I hope you're able to understand what I'm trying to say here. Let's move forward to the next part. Now let's go ahead and analyze this. That is y is equal to 3x squared plus 2x plus 5. Again, what I'm going to do is I'm actually going to try to split this. 5 times 3 is 15, right, which is actually there. So 3x squared plus so 5 times 3 is 50. Now over here I can sense that I might not be able to split the middle term. So what I'm going to do is I'm actually going to use the formula. So the roots are going to be minus b plus or minus square root b square minus 4ac divided by 2 times a. So as you can see that this is going to be a negative number. That means the roots are going to be imaginary, right? If the roots are going to be imaginary, that means the graph is going to hang in the air. It's not going to touch the x-axis at all. Another thing is that if I want to find out the value of y-intercept, just put x as 0. If you put x as 0, y would be equal to 5. That means this value right here is going to be equal to y is equal to 5. You want to find the x coordinate of this point. The x coordinate of this point would be equal to minus b over 2a, right? So the x coordinate of this point is going to be equal to minus b over 2a. So that means so that's what it's going to be. So I hope you're able to understand what I'm trying to say here, guys. Now let's go ahead and solve some questions on it. So this question over here says that what is the product of the roots of this function? So if I have this quadratic function 3x squared minus 6x minus 4 is 0, what is going to be the product of the roots? Product of the roots, as you know, is equal to c over a. C is negative 4 and a is 3. That means the product of the roots is actually equal to negative 4 by 3. So I hope you're able to understand this question over here. Now you can see you can do these questions in under 30 seconds. They're very, very easy. Now this says the coordinates of the vertex of the parabola whose equation are, so we have to find the coordinates of the vertex of the parabola. So the function is this. The x coordinate of the vertex can be found by minus b over 2a. That means the x coordinate of the vertex is going to be equal to minus 4 over 2 times 2. So that is actually equal to -1. Fine. So the x coordinate of the function is actually going to be equal to, let me just verify, it's minus b over 2a. So x is equal to -1, right? So and y is going to be equal to 2 into -1 square plus 4 into -1 and -5. That is going to be equal to 2, -4 and -5. That is equal to 2 into -9. That is -7. That means the coordinates of the vertex are going to be -1 and -7. So I hope you're understanding this point here, guys. Let's move forward to the next one. So this question is asking the range of the value. So if I want to find out the range of the value, I have to check all the values of y. First thing, as you can see, that the function is of this sort. That means a is negative. That means the function is going to be like this. And let's find the value of this, the x coordinate of this. So the x coordinate of this is going to be minus b, that is minus of -4 divided by 2 times a, that is -1. So minus b over a is going to be 4 over -2, that is actually equal to -2. That means the x coordinate here is actually equal to -2. So if x is -2, what is y? Y is going to be equal to minus of -2 square minus 4 minus 2 plus 5. That is going to be equal to -4, +8 and +5, which is going to be equal to 4 plus 5, that is 9. That means the y value here is 9. That means y is something which will always less than or equal to 9. Because this is this kind of a function, y will always remain less than or equal to 9. As you can see there, y value cannot go beyond 9. So this is how you find the range of the function, right? So you should not be getting these questions wrong. These are, one of the most easiest questions that you'll find on the SAT subject test. Let's move forward to this one. This says that equation of the axis of symmetry of the function is this. So we have to find the equation of the axis of symmetry. So y is equal to, y is equal to 2, I'm sorry, this is supposed to be x, 2x square plus 3x minus 6. Now the axis of symmetry would be x is equal to minus b over 2a. So that means it's going to be x is equal to minus 3 over 2 times 2. That is actually equal to x is equal to minus 3 over 4 is going to be the equation of the axis of symmetry. So I hope you're getting this point over here, guys. Let's move forward to the next one. So this says find the roots of this function. So y is equal to 2x square plus x minus 6. Just use the formula minus b plus or minus square root b square minus 4 into a into c over 2 times a. So that is going to be minus 1 plus or minus square root of 1. So this is 6 times 4 is 24. 24 into 2 is 48. So 1 plus 48 over 4, because negative into negative will become positive. So this is -1 square plus or minus square root 49 over 4. This is going to be equal to -1 plus or minus 7 over 4, which, so you can actually convert this into 2. That is -1 -7 over 4 and -1 +7 over 4, which is going to be equal to -8 over 4 or +6 over 4, which is -2 or +1.5. Fine. So I hope you're able to get what I'm trying to say here, guys. So this is the answer, that is -2 and +2.5, +1.5. Let's see this question. He says find the sum of the roots. So sum of the roots is actually equal to minus b over a. So minus b is 6 and a is 3. So sum of the roots is 2. Pretty easy question. Let's see this one. So x square plus 2x plus 3. Let's find b square minus 4ac. That is the value of the discriminant. That is going to be b square minus 4 into a into c. That is going to be 4 minus 12, that is -8. Now discriminant is less than 0. When discriminant is negative, you have two imaginary roots, right? So when you have two imaginary roots, which is answer option E, that is two complex conjugate roots. right? So something that you can easily verify from the theory that we've done in the beginning. Let's try another one. This one says that a parabola with vertical axis has its vertex at origin. So it has its vertex at the origin. Let's say this is the origin. It has its vertex here, right? And it says that it passes through point 7 comma 7 and it also passes through point 7 comma 7. The parabola intersect line y is equal to 6 at 2 points. What is y is equal to 6? This is y is equal to 6. So it passes through y is equal to 6 at two different points. The length of the line segment joining these points. So he wants the length from here all the way till here. Now, as you know that since if the vertex is at the origin cuts, the y-axis cuts the graph into two equal parts. That means this is equal to this. Fine. So this is something which is equal to this, and the 7 comma 7 is actually on the line. Now, first of all, the line of symmetry is actually equal to minus b over 2a. And here the line of symmetry is x is equal to 0 because this is the y-axis, the vertex lies on the origin. That means that the value of b is going to be 0. Fine. The value of b is actually going to be equal to 0. And if the vertex is on the origin, the function is going to be simply ax squared. Even c is going to be 0. Now, because c is something that pushes the graph up or down the x-axis. If you look at the graph carefully, if I say y is equal to x square, y is equal to x square looks something like this. If I say y is equal to x square plus 2, it will actually look like this. So this constant term is responsible for moving the graph up, or it's responsible for moving the graph down. This is something that we're going to be doing in the future videos in transformations. That means if the parabola passes through if the vertex is at the origin, that means the equation of the parabola is going to be equal to y is equal to x squared. And as you can see that 7 comma 7 passes through this function. I'm going to substitute 7 comma 7 here. 7, that is y, is equal to a into 7 square. That means a is equal to 1 over 7. That means the equation of the function is y is equal to x square over 7. That is the value of this equation. Now, at x is equal to at y is equal to 6, what is going to be the value of x? If I substitute y is equal to 6 here, I'll have 6 is equal to x square over 7. That means x square is equal to 42. That means x is equal to plus or minus square root 42. That means this is equal to plus square root 42 and this is equal to minus square root 42. That means the distance from here till here is square root 42 and distance from here till here is square root 42. That means the total distance that I'm looking for is actually equal to 2 times square root 42. And if you put that in your calculator, if you try to find the value of 2 times square root 42, that is actually going to be approximately, so as you know, this is going to be 6 point something, and if you multiply that by 2, you'll get straightforwardly 13, and 13 is going to be my answer. So I hope you're able to understand what I'm trying to say here, guys. What I established here is that if the vertex is at the origin, the value of b is 0 and the value of c is 0, and the quadratic function just stays y is equal to ax square. We're going to be doing that in depth in the transformation videos, and it passes through 7 comma 7. When x is 7, y is 7, and from here we got the value of a. Once we got the value of a, we substituted x is equal to y is equal to 6 and got the value of x, and we got two different values, and one value is this and one value is this, and we just found out what is the distance between this x value to this x value, which is 2 square root 42. We approximated it, and this is going to be the answer. So sorry. Alright, so guys, thank you very much for watching this video, and thank you very much for watching this video. I hope you're able to understand the quadratic functions with respect to SAT math subject test, right? So this is the course on SAT math subject test. We're just concerned about SAT math subject test in this video, right? So just keep watching the videos, and I will see you in the next one.